Find the percent of a number. Sometimes we have to use computation when working with percents. So one method is to write the percent as a fraction. Since 20% means 20 out of 100, I'm going to write it as 20 over 100. Of always means multiplication because it's taking a piece of a piece. And 25 as a fraction is 25 over 1. Now I simply multiply my numerators and then multiply my denominators. However, before I go and work with big numbers, I can reduce some of my fractions and make the math a little bit easier. So 20 over 100 reduces down to 1/5. 1 times 25 is 25. 5 times 1 is 5. This is an improper fraction. 25 over 5 becomes 5 with no remaining numbers. So 20% of 25 is 5. The second method is to take your percents and to write them as a decimal. So 20% as a decimal is 0.20. Again, of multiplication, 25. 25 times 0.20. We can ignore the 0, right? 5 times is 10. And regroup, and we get 5. We got 0 decimal places, 2 decimal places, which means we need a total of 2 decimal places. Again, 20% of 25 is 5. Both methods work. It's just personal preference. Okay, write the percent as a fraction again. On this problem, we have 15 over 100 times 110 over 1. We can reduce this fraction by dividing by 5 in the numerator and 5 in the denominator, but there's another way you can reduce, and we're going to take a look at this a little bit further. 100 and 110, we can go diagonal, can both be divided by 10. So 100 divided by 10 is 10, and 110 divided by 10 is 11. I can now multiply my numerators. 15 times 11 is 165. 10 times 1 is 10. 10 goes into 165 16 times with the remaining 5 tenths. Okay, again, 0.15 times 110. 110 times 0.15, okay? 0 decimals, 2 decimals. If you work out the computation, you will get 1650. We need 2 decimal places, 1, 2, so we get 16.5. 16.5 and 16 5/10 is the exact same value. We just have them in 2 different forms. We'll do one more together. 5% of 30, 5 over 100 times 30 over 1. You don't have to reduce your fractions. However, we'll have to work with larger numbers, and then you're going to have to reduce them at the end anyway. So I'm going to reduce this to 1/20, and then I can also reduce it diagonally. 20 and 30 can be divided by 10, and I get 2 and 3. 1 times 3 is 3. 2 times 1 is 2. 1 and 1/2. Okay? For those of you who don't see the crazy reducing I'm doing, 5 times 30 is 150. 100 times 1 is 100. 100 goes into 150 one time with 50 out of 100 remaining, which is 1 and 1/2. Either way, you come up with the answer 1 1/2. Okay, now here's where you need to be careful. If you choose to work with decimals, you have to remember that 5% is not 0.5. It's 0.05. 5 out of 100. 5 hundredths of 30. 30 times 0.05, 0 decimal places, 2 decimal places, and we have 150. Actually, it ends up looking like that. If you do all the computation, we need 2 decimal places, boom, boom, right there. We have 1.50 or 1.5, which is also 1.5. We're going to work on this reducing that we saw up in method 1. We're going to work on that a little bit more in class, so if that's confusing, that's fine. Just use the method without the reducing by multiplying your numerators and your denominators. Personally, I like decimals. I think they're just easier. However, where we often make our mistake is right here when those decimals are not as clear as the fractions over 100.